Hello everyone, and welcome to this lesson called Bond Pricing and Time Value of Money, or the Time Value of Money, the TVM. This is one of the most sort of fundamental lessons in the whole fixed income section of the curriculum, where we will explore the very essence of bond pricing and the relationship between price and yield. So an important one to watch and key takeaways from here, as it also applies to the other lessons that follow. Right, let's begin with a very obvious statement. Bond pricing, which is actually, this statement is going to be true for the valuation of many assets or the pricing of many assets. It's all about discounted cash flows. It's all about taking projections of future cash flows that a specific asset we expect will generate, and or it promises to generate for us, like in the case of fixed income instruments, and discounting it to reveal its present value. And of course, in order to do that, you're going to have both future cash flows impacting the valuation, the exercise, the pricing exercise, but also your chosen interest rate, which we will be also referring to as the discount rate. That's going to be critical. And in this initial lesson, we will slowly progress towards using the yield to maturity as a synonym for the discount rate. But, for now, let's say that this is going to be the market discount rate. And that's going to mean the rate or the rate of return required by investors given the risk of the bond, the riskiness of the bond. This will primarily relate to the credit risk of the bond, but also the liquidity risk of the bond. So we're talking about the yield spread above the government required rate, the rate of return required on government bonds. More discussions on that in the factors affecting yield spreads recording. Right. So this will in effect produce for us, and this is the same as the market discount rate is synonymous with the required yield, basically, and we'll be using these terms interchangeably, or the required rate of return. Right, enough of the talking. Let's actually do a numerical question, because in this section of the curriculum we are fortunate to be able to compute quite a lot of stuff, which makes for a change, because until now I've been doing a lot of theoretical questions, at least quite recently, but now a good opportunity to get our calculators out. So here's a simple question. The value of a 4-year Spanish government €1,000 principal value, 3.6% annual coupon bond, price to yield 4.2% is closest to. Now this 4.2% is the required yield, or the market discount rate. Simply put, required yield. And that's going to be effectively the discount rate that we will be using to discount future cash flows. It's a simple annual coupon bond, paying coupons once per year. So just very simply, I won't necessarily be doing this in later modules or in later videos. If you take a timeline, and if you say, well, this is time 0 effectively now, end of year 1, end of year 2, end of year 3, and let's just check. Okay, we need one more year, don't we? Because this was supposed to be a 4-year Spanish government bond. Principal value 1,000. That's synonymous with face value or par value. So this is what the investor will effectively receive at the end of the bond's life over here upon the maturity, 4 years out. And in the meantime, they will get a coupon. Now the coupon is 3.6% paid annually. The coupon rate is always expressed in annualized terms. So 3.6% per year. How do you convert that into actual, euros? Yes, this was a Spanish government bond denominated in euros. So you take the 3.6% and you multiply by the nominal value of the bond, which effectively is 1,000. We know that from over here. It's the principal or the face or the par or the nominal value of the bond. And that gives you simply 36 euros per year of coupon. So that's 1,000 euros over here, but we also get an assumed 36 once a year. This typically gets paid in arrears at the end of the period. So like this. Now we could do some discounting in the old, discounting using the old school way, taking each of these cash flows and discounting over time to get present value. And this is something I practiced with you in the, in the sort of introductory time value of money recordings, which you'll find in a separate playlist on this channel. But, we have much easier ways to do this using the time value of money worksheet, which I'm going to fire up in just a moment. So using the TVM worksheet on our calculators, what we can quite easily do is provide the calculator with some inputs. We need the number of periods, that's n, to equal 4, because we've got 4 years to maturity. We also want to tell the calculator what the interest rate or yield is, so what rate to use for discounting purposes, and that comes under the heading or under the symbol I over y. We need to make sure that the calculator discounts using 4.2 as the interest rate or the discount rate. Now there's also an element of regular payment here, so PMT is going to equal 36, and we also need to tell the calculator that a V is set at 1,000. Now before you get hold of your calculators and start putting things in, let me take mine and start recording its screen. Please, whenever you go to the time value of money worksheet starting on a fresh problem, clear whatever may be in there from previous problems, and you do this by pressing second followed by FV. So second, the key on the left hand side, followed by FV, which has clear time value of money as its secondary function. Nothing spectacular will happen, but this clears any residual data, which is a good idea before you start on a problem. And now in any order, it doesn't have to be particularly this order, you input the data, but bear in mind, you first input the number and then you tell the calculator what it is. So 4 in my case followed by n, and you'll see now the calculator displays n equal to 4, or 4.2 for I over y, but once again first press 4.2 and then I over y. Same thing for 36 and PMT, and 1000 for FV. Okay, and now I'm going to get my calculator to compute the PV, which is basically the price today. After all, this is what we were asked about. What's the value of the bond today? So CPT in the upper left hand corner of your calculator keys, followed by PV. Oh, and there you see it. It's 978.32. It's expressed as a negative number because the inflows are that you'll get the cash flows like the coupon, and the FV, the future value, the principal value, were keyed in as positive numbers. So it says you have to kind of suffer a cash outlay of 978.32 today to get the get those cash flows in the future. Right. Negative number doesn't mean negative value. Answer was A, and later on we'll talk about the relationship between the coupon and the required yield in terms of producing numbers which are either below the par value or above the par value, below 1,000 or above 1,000, depending on that relationship. Well, let's move on to a second question, this time slightly more complicated, because once again we are supposed to, over here, do a computation of price, but we'll be asked for two prices, one today and another in 3 years' time, effectively, so sometime later. And that's one complication. The other is this bond pays coupons semi-annually instead of annually. Now, in later lessons, when we get to notions of periodicity, there'll be more, definitely more explanations of the ways in which we handle, coupon payment frequencies and how we compute various measures associated with these. But for now, I'm just going to show you the most basic approach. We are told that this, what is the price per 100 of par value? So we're not given a specific par value. We're just told, look, assume it's 100, or for each 100 of par value of a 10-year 5% semi-annual coupon bond, if current interest rates are 4.6%. And what will be the price of the bond in 3 years from today, assuming interest rates do not change during those 3 years? Right. The thing is, a lot of people get this wrong. If you are given a 5% semi-annual, if you're told that this is a 5%, semi-annual coupon bond, don't make the mistake of thinking that it pays you 5% every 6 months. No, the coupon rate, 5%, is always stated in annual terms, right? So, always stated on a per year basis. The only thing that semi-annual here kind of means is this effectively is 5% times the par value. The par value here we're going to assume 100, which gives us 5, and that is split equally into 2 semi-annual payments, each one being 2.5 every 6 months. So every 6 months you get a payment of 2.5, which gives in total 5 during the year. That's 5% of par value. That's the way to understand it. Now, how do we perform the computations? Well, just like before, we utilize the time value of money. So let me write out the inputs first, and then we'll, try to key them into the calculator. Before I do any inputs into the calculator, I'm writing things out on paper first. So we need a number for n. That's the number of periods. However, don't make the mistake once again of taking 10, which would come from the fact that this is a 10-year bond. It's not going to be 10. Here you have to think in terms of periods, the number of periods. So 10, critically, times 2 to give us 20 semi-annual periods, or 10 years. But we have to go down to the scale of, the interval between coupon payments when using the time value of money in the context of bonds. Now, FV, future value, is simply 100. PMT, that's the coupon, the regular coupon, that's going to be 2.5 because it's 2.5 per period, but 5 per year. And very importantly, you also have to scale the interest rate. This is effectively our discount, this effectively is our discount rate, or the required rate of return. That's what you have to tell the calculator to use to do the discounting. However, right, once again, scale everything down to a semi-annual period. So our I over Y, I'm laughing because the church bells have decided to go off. Okay, that happens in the afternoon where I live. Now, you may pick that up in the recording. The I over Y is therefore that 4.6, but once again scaled by dividing it by 2 to effectively give 3.2. That's pretty much it. Sorry, not 3.2. Got it the wrong way around. 2.3, isn't it? 2.3. Easy to make a mistake when you're talking and trying to compute at the same time. And I'm once again going to get my calculator to compute CPT PV. Let's see what happens if we make these inputs. So let me start the recording again. Right, here we go. I still have on my calculator the previous result, and as I said, it's a good idea to clear everything first. So second followed by ever v, which has clear time value of money as its secondary function. And now let's go for 20 for n, 100 for ever v, 2.5 for PMT. As you can see, the order is completely irrelevant. 2.3 for I over y. And by the way, if you want to avoid this, making a silly mistake like I did, putting in 3.2 instead of 2.3, you can easily just tell your calculator, look, 4.6 divided by 2 equals 2.3, and make this I over y, right? Your calculator will deal with that completely fine. And now I'm pressing compute followed by PV, and out pops an answer of negative, because it's a price to pay, 103 point, well, let's round it to 18. Let's see if there's an answer that corresponds to this. Well, the value today is, yes, it's one of these, B or C. Now the question is, what is the value in 3 years' time? I can tell you for sure that it's going to be this one. How do I know? Well, let's figure this out. First of all, you could do this the long way and actually do the computation. So if this was the value today, underneath I'm going to have the value in 3 years' time. And because my calculator already has all the inputs on it, you can see that answer 103.17, whatever, still displayed, and the inputs are still stored. This is the one time where you don't necessarily want to clear the time value of money worksheet, because the inputs stored are still relevant. What I would do if I needed to calculate this is I would just override the n input, the input for n, and I would make n a changed value. In 3 years' time, this bond will still have 7 years until maturity left. And 7 years until maturity times 2 periods per year. Remember, we're thinking in terms of 6 monthly semi-annual periods, will give 14 coupon payments left. So if I replace 14, or type in 14 followed by n, your calculator will now know to replace the relevant input. And if I do CPT PV, so I recompute present value, it will produce a result of minus 102.37. So that's the price I would need to have to pay for the bond in 3 years' time, assuming, especially this discount rate hadn't changed. So assuming interest rates do not change. And look, 102.47. Okay, so I made a blunder of it, didn't I? Because I previously highlighted, oh, what a shame, I looked at it wrongly. It wasn't B. Oh, what a stupid mistake to make. Let's get rid of this. It's a sign of my weakness there. It had to be C. Oh, got confused with numbers again on this recording. So it had to be C. Apologies for that. Why did it have to be C? Well, because this bond initially traded at a premium to its par value, and with the passage of time, that premium has a tendency to go low, to get lower. Now, because I made a mistake, hopefully you'll remember it now, the rule for it. I'm going to write it down in just a few minutes. Ooh. Answer C is the right one. Apologies for that confusion. Now, this question is important because it gets us to think about two important properties, so to speak. First of all, a very critical relationship when it comes to the size of the coupon rate. In each of the questions analyzed thus far, we had a coupon rate and we had the required rate of return. So depending on the relationship between the coupon rate and the required rate of return, the one that we were inputting under I over Y, will get very different results, starting with a situation where the coupon rate is lower than the required rate of return. That was in fact the case in the first question that we did together, this one. You see, the coupon was 3.6, but investors required a yield of 4.2, and that's how the bond was priced to generate that yield or required rate of return. And look, the answer which we got in terms of the price was lower than 1,000, lower than the par value. In general, bonds whose coupon rate is lower than the required rate of return in the market trade at a discount to their par value. So over here, let me write simply bond price and say bond price is going to be at a discount to par value, to nominal or face value. On the other hand, if the coupon rate which the bond offers is higher, better than the required rate of return in the market, so the bond is basically offering you more than what you require from it, it's going to be relatively attractive in the market, so it's going to trade at a premium. So premium to par, above par value, and that was the case in the second question, where the bond was offering a 5% coupon. The fact that it was semi-annual doesn't matter, but interest rates in market were just 4.6, so this bond was effectively offering investors something that was overly, excessively attractive, and they were willing, or they should be willing, to pay a premium for it. Okay, now the third possible situation is one where the coupon rate equals exactly the required rate of return, not rate of rate, that's completely rubbish, sorry, let me get this out, return, and return again, apologies for that. An important recording, but I seem to be making quite a few blunders here. That's where the bond price will be equal to par. The bond will trade at what we call par. And very often when corporate issuers issue notes and bonds, they try to get the coupon just right so that they can sell the issue at as close as possible to its par value. Yeah, that's what happens. Now, the other point that I want to make on the back of these two questions, especially the last one, is something called the constant yield price trajectory. And this is what, in theory, should allow you to answer this question without having to compute the value in 3 years' time. This is what I got wrong, but I just picked the wrong answer, not because I don't know the rule. I looked at the numbers wrong again today. So, assuming market discount rates or market interest rates do not change, so they stay constant, basically, remain constant. And in our question number 2, that was effectively what we were asked to assume. Assuming interest rates do not change, what's going to be the value of the bond in 3 years' time after another 3 years? Well, if you've got a bond that initially trades at a premium or a discount, that premium or discount will indeed persist, but over time it will get eroded down to zero. So when we get to the maturity date, the bond will be worth exactly as the amount you're just going to receive in a moment's time as an investor, and that's going to be the par value. So as we get closer to maturity, the investor is getting closer to receiving the par value, 1,000, 100, whatever that may be. So this is called the pull to par, or as we may say, the bond is being pulled to par to a premium or discount of 0. It doesn't mean the bond is worth 0. The premium or discount is going to zero out. And if you want to plot this on potentially a chart, what you would have is over here the price of the bond. Over here you'd have time. And let's say that somewhere here we've got the par of the bond in G100. That was the case with the bond in question number 2, in the second question, right? Assuming a par of 100. Initially, the bond begun at what priced at 103.18, so with a relatively sort of sizable, hefty not discount, premium, 103.18. But as time passed, or time was passing, 3 years later, that bond was trading at just 102.37, so with less of a discount. And if we measured the price at other points in time, that price would be smaller and smaller still. So what happens is, it will, over time, get closer. That price will get closer and closer to the par value. And if you had a bond trading at a discount, of course, that discount would get eroded away, and the bond would get pulled up towards the par. So with premium bonds or bonds trading at a premium, it's that premium which gets eroded and drawn to 0. With discount bonds, bonds trading at a discount, it's the other way around. It's the discount that goes down to 0, but the bond price therefore goes up. More on that in definitely in later sections of the topic, of the fixed income topic. Right, now for the final section of the video, once again quite important, we will discuss something known as the YTM, which stands for the yield to maturity, and this is once again something that's going to be discussed over and over in subsequent sort of numerical sections of this topic area. The yield to maturity, if you know anything from corporate issuers already, you can think of this as the internal... Sorry, my computer is not doing very well anymore with these, with my writing. Internal rate of return on the cash flows generated by the bond. And the IRR is typically invested for investment project, is computed for investment projects, but I guess buying a bond is a bit like entering some kind of investment project, for lack of a better word. And the point is, if you were to use this YTM, which is an interest rate, the yield to maturity, to discount all of the individual cash flows of a bond, you would arrive at the bond price. So the way to write this down is as follows, or one way to write this down: if we use the yield to maturity to discount, of course taking into account the relevant periods of time, discount all future cash flows from that investment, we will arrive at a sum of the present values that equals the bond price. Okay. A lot of the time people call this, or refer to the YTM as the implied from the bond price and the cash flows of the bond, or observed single, because it's just a single number, market discount rate. I mean, as we progress through the curriculum with these recordings, you'll kind of get more and more of a feel for what we're talking about here, essentially. Now, at this early stage, I want to introduce some very important conditions which are not just true for the yield to maturity, but they're also true for the internal rate of return in any investment scenario. If you are an investor and you know that a bond is trading at a certain YTM, a certain yield to maturity, there are certain conditions that are still necessary for the investor to really earn that YTM, right? It's not just enough to buy the bond for a specific price and expect to earn the YTM, the yield to maturity, over its lifetime. The conditions are that as an investor, you must hold the bond until maturity. That's why it's called the yield to maturity. Investor holds the bond all the way until maturity, because if you sell your investment, sell the bond before the maturity date, there is no guarantee what price you'll get, and therefore the whole idea of calculating a yield that's based on receiving the par value at the end of the bond's life, well, that gets thrown out of the window. Second, you must receive all the coupons and principal payments, effectively, the par value at the end of the bond's life. But some bonds pay par in an amortized way, so across their lifetime, and principal payments are received on time, on the scheduled dates. So not earlier, and definitely not later either, on scheduled dates. And I think the least appreciated point is, because the previous two are kind of quite straightforward, is that the only way to earn a rate of return, a real rate of return, a holding period return on an investment into bonds that would be equal to the YTM, is if all the coupons which you received before the maturity date are reinvested at a rate equal to the YTM, okay, until the bond matures. So it's only if you take all the intermittent cash flows, all the coupons, and you are able to put them into some kind of investment that also generates a rate of return equal to the same YTM, that you'll be able to claim that you've generated a overall return on your investment equal to the YTM until the bond matures. Okay. This is sometimes tested theoretically. The fact that you know this last point as well, it's important, but don't think about it too much for now. There will be plenty of opportunities to kind of mention it in the future as well. I will from time to time be popping that. That will pop up, to be honest. Now, you can use the term YTM, yield to maturity, interchangeably with discount rate from now on, and interchangeably with the required rate of return. So depending on question, depending on context, we'll be saying market discount rate, or simply discount rate, required rate of return, or yield to maturity, same thing. And very importantly, in case you haven't you don't know this already, bond prices and yields, so the yield to maturity, for example, move in absolutely opposite directions. A bond is a series typically of fixed cash flows that are promised to you in advance, like over here. A bond is promising to pay you, or the bond's issuer actually is promising to give you something in the future. And if you pay a higher price, you'll squeeze less rate of return or less yield out of it. If, on the other hand, you want to earn more yield, a higher rate of return, you need to pay a lower price. So, this idea of moving in opposite directions is very fundamental to thinking about bonds. So, for example, we can say that the yields are rising on bonds. Yields are rising, and that kind of already implicates that bond prices are falling. And if bond prices are falling, that means the yields are rising. Or if bond prices are rising, yields are falling. And if yields are falling, that means bond prices are rising. It's all one and the same, but please make sure to kind of observe the fact that we've got opposite directions over here. Right, and just one more question, to finish things off here in this little video. We're going to do once again a numerical question, this time to calculate the yield to maturity. It's going to involve a semi-annual coupon bond trading at 97.25 per each 100 of par value. The annual yield to maturity, or also known as the annualized yield to maturity for this 7-year 6.4% semi-annual coupon bond, what is it? Well, take a little look at the question. Please appreciate that this bond is trading at a discount. Now, you should be able to solve this question without doing any number crunching, to be honest, with just that observation. This is the way to save time in the exam. But, let's do it the long way anyway. Take your calculators. I've just pressed the record button on my calculator, and here is the screen. I still have my results from a previous question. So, second followed by clear time value of money to clear the worksheet. And now, what do I need to put in? Well, I need to have a value for n, and I'm going to make this, well, it's a 7-year bond, but because it pays coupon semi-annually, I need to make this 7 times 2. So that's going to be my 14 for n, 14n. Okay, what about PMT? Well, my input for PMT, it says here, it's a 6.4% semi-annual coupon bond, but the PMT is 6.4 divided by 2, isn't it? So 6.4 divided by 2, that equals, whoops, did something wrong there. 6.4 divided by 2 equals, well, this time it's 3.2. It wasn't the previous time when I tried to put that in. That's going to be my PMT. And you could say, well, why are you doing this with rates? Because we're assuming 100% par value here, 6.4% of 100 or 3.2% of 100 is 6.4 or 3.2 respectively, be it euros, dollars, or whatever. So this is a very easy way of dealing with the inputs, bond-related inputs, 3.2 again. What else do we need? This time we're given a present value. We're given a price, 97.24, and I've got to be very careful here to make this negative. So it's a negative 97.24 for the price input. You make it negative by pressing the plus stroke minus key. Okay, that's PV. And we have for FV, for future value, a nice round 100, don't we? 100 future value. And what do we need to compute? Well, this time we need to compute the yield. So CPT, compute I over Y. And if I press that on my calculator, CPT I over Y, out pops 3.45. Now there is an answer A, that reads 3.45, but that would be the wrong one. Why? Well, it's very catching it's very attractive, kind of pulls you in. It wants you to say yes, 3.45, but that would be wrong. This is stated on a per 6-month period basis, and whenever you quote yields or rates in finance, you do it on an annualized basis. We are asked specifically for the annual or annualized yield. Even if you're not told that, assume it's annual. Sometimes in the exam you just have to kind of know what to assume. So multiply that by 2 effectively, and you get, well, you get 6.9, don't you? 6.90, yeah, this one. So it's answer B. Now, the other way to have known that without doing any computation was the bond was trading at a discount to par value. And if you go back to the general rules which we wrote down a few minutes ago regarding the relationship between bond prices and coupon rates, if you've got a bond trading at a discount like we had in this question, it means the required rate of return must be higher than the coupon rate which the bond is offering. There is no sort of other way to get this relationship. So if the required rate is bigger than the coupon rate, let's go back to the numbers and observe what actually potentially makes sense here. Where was this question here, right? The bond was offering 6.4, and the only required rate of return that is indeed higher is 6.9. If the bond trades at a discount, it means the coupon rate which the bond is offering is too low compared to what investors require. Required rate of return, and we said, okay, you can use YTM as a synonym for required rate of return. Is basically the same thing, and the only number that satisfies that relationship or that condition is indeed 6.9.